Hello, boys and girls. This is the course of Environmental Science, and I am G. Chakraborty from Department of Chemistry, welcoming you to this course of Environmental Science.
Now, what you have done in these 23 lectures, I will not tell it right now. We will discuss that at the end when we will conclude the chapter and we'll conclude this total course, right? Then we'll discuss about it. So, at this moment, we'll just discuss a little bit about noise pollution. We will recap what we have studied in noise pollution in the last lecture, and then we'll move into this particular lecture. Okay, so in the last lecture we have seen that what is basically noise, and we have come across the fact that noise is a relative term. It may happen that for me it is a noise, but for you it is a sound. Okay, so it is a relative term that varies from man to man. That's why we have introduced the dBA scale, and using dBA scale we can determine whether particular sound is noise or not. We have also seen that if two persons are sitting at a distance of 1 meter, then 65 dB sound is good, 100 dB sound is extreme, 135 is very painful, and 150 will take life. Okay, so it is not that easy. It's quite difficult. Okay, now we have also come across the fact that what are the different types of anthropogenic noise. We have seen that transport noise is there, occupational noise is there, neighborhood noise is there. Okay, and transport noise can further be divided into rail, road, and aircraft noise. Okay, so several things we have seen. Physiological effects also we have seen. Now let us see what we are having in this lecture. As you can see, this is the noise pollution, and we are watching lecture 2 of this noise pollution. Not lecture 2, it is rather part 2. It's lecture number 24. Now this particular lecture has several topics. As you people can see, large number of topics are present. It starts from the very own definition of noise frequency and noise pressure, right, followed by noise intensity, noise level. So these 4 definitions will be there. Now we'll be having mathematical expression of decibel, which will be used to solve some related problems. Then we'll see what is noise threshold limit value, what is equivalent noise level, and what is L10 index, that is 18 hours index. Okay, that we will see. Now whenever we will move to the intensity of noise, what we people will be seeing that intensity is a very important parameter, right? And this parameter will tell us clearly that what to deal with and how to deal with. Okay, let us see what we are having. The intensity of noise, or the noise intensity, or the sound intensity, is expressed in terms of decibel. Now with this we know very well that decibel is the unit of measurement of noise. Okay, now generally sound intensity from 0 to 100 decibel is considered to be pleasant. When it exceeds 120 dB, it causes noise. Okay, now this is worth remembering. Remember it very well, that 0 to 100 decibel sound is good, is pleasant for all of us, but when it is 120 decibel or more than that, then it is considered to be noise, right? Okay, 120 decibel is the extreme limit. More than that, it is considered noise. Sound intensity of 130 decibel is the upper limit of hearing, and beyond this is threshold of noise causing pain to ear, right? Now if 130 decibel sound is something you are hearing, then be very careful. You are going to face huge hear related problem as well as pain in ears. If 130 dB sound, you are hearing sound more than 130 dB, hence causes noise pollution. Okay, this is very important. 120 dB is causing noise, and 130 dB will cause pain to ears, right? And 0 to 100 dB is pleasant. The two important parameters of sound are sound pressure and intensity, right? We'll discuss about those. And common unit of noise pollution is decibel. Noise, actually, not pollution. Common unit of noise is decibel. Now we need to see how decibel is calculated mathematically. Okay, as you can see, we are having a mathematical expression right here. Okay, so we'll be seeing what we people are having here. This is the mathematical expression that we are having. Okay, and let us find out what is present here, right? As you can see, this is the expression that we are having, and it is written that decibel, that is dB, is equal to log 10 base 10 into log 10 base 10 I by I0. Always remember this formula. This is not that much difficult. It is quite easy to remember. So you need to remember this, that decibel is equal to 10 log 10 I by I0, where I is measured intensity and I0 is the reference intensity. Okay, this is the formula that we'll use to solve numericals. Okay, but before solving numericals and all, we need to see that what is frequency and what is noise pressure, right? Now, as we people will move further, we'll see that frequency is nothing but the number of wave that passes through a point in 1 second, or number of oscillations per second, and SI unit is frequency is hertz or cycles per second. Now this is nothing but a term from physics which people have studied multiple times, right? This type of things, that frequency is nothing but the total number of waves that are passing in 1 second. It is basically expressed in oscillation per second or cycle per second, right? Okay, and the SI unit of frequency is hertz, Hz. Okay, next comes noise pressure. Now pressure is always force per unit area. The sound waves creating pressure on the medium through which it propagates is measured in Newton per meter square. Okay, definition is same. Pressure is force per unit area, and the unit which is used to measure it is Newton per meter square. Now here comes L10 index or the 18 hours index. What is the meaning of this particular thing? It is basically the arithmetic average hourly values of the noise level exceeds for the 10% time over 18 hours between 6 to 24 hours of any normal weekday. Scale is used to measure road noise in UK. Just try to understand. We are doing here for 18 hours and we are using L10 index. Now here L10, that is the digit 10, refers to the 10% exceed in the noise level, and this 18 hours are nothing but starting from morning 6 am to midnight. Okay, morning 6 am to midnight. Now basically, in order to calculate or in order to determine the traffic noise of UK, London, right, what has been done? This particular scale has been implemented, this particular scale has been used, right? So it measures the noise for this 18 hours of the day, starting from morning 6 am to midnight, and it has been observed that during this time period there is an increase in 10% of the normal sound level. Okay, now next we people are having equivalent noise level and the noise threshold limit values, as you people can see here. Okay, now what is equivalent noise level? It is the weight average sound level over time of measurement and is represented by LEQ expressed in dBA unit. So weight average sound level over time of measurement, that is what equivalent noise level is. Time of measurement is specific and measurement of short duration, usually when the noise level is most prominent. So this particular noise is measured when the noise level is maximum prominent, and it is a measurement is done for a different time during the value will differ. That definitely will differ in different times of the day. If the measurement is done in specific period of time started and the same time in different place, it may not be same. Yeah, absolutely. Suppose a noise is measured for 1 hour. Now this 1 hour is morning 7 a.m. and evening 7 a.m. At morning 7 a.m. the noise will be very less. At evening 7 a.m. the noise will be very high. So definitely it depends on the time at which the noise has been captured. It's not that only the duration only, right? It depends on the time at which this has been implemented, right? Now this particular unit is very important as it has been accepted by the International Organization for Standardization, that is ISO. This ISO approved, so it's very important for us. Another is the noise threshold limit values. This is also very important. When daily noise exposure is composed of 2 to more hours at different levels, the combined effect is considered to be more than the individual effect, where the sum of the following fractions C1, T1, C2, T2, etc. exceeds unity, and is the mixed exposure is considered to exceed the noise limit value. Cn indicates the total duration and Tn indicates the total duration of the exposure permitted at that level. So basically what we are trying to see, noise threshold limit value is nothing but a noise which continues for longer periods of time. For that we'll use this particular formula where Cn and Tn has their unique usual significance, and we will do the calculation in that way only, right? So this was the basic things about noise pollution. One more thing I would like to discuss. Let's go back. Here, as you people can have seen, we have explained what is definition of noise frequency, noise pressure, noise intensity, noise level. Mathematical expression of decibel we have explained, and these three also we have explained. But what about this one? What about this one? Decibel related problem. We need to do it. Okay, so let's do it. Just I'll make you understand how this particular thing works. Basically, question will come like this: that calculate the intensity of 100 dBA sound, right? Again, I'm saying calculate the intensity of 100 dB sound. So what we are going to do? We are going to write like this. Say, let me take the pen. Yeah, we are going to write that. Let us write the question first. So the problem is calculate the intensity of 100 dB sound. If the reference intensity is 1 into 10 to the power minus 24, say watt per meter to the power square. Okay, suppose this is our problem. Now how we can solve this problem, that we need to see. How this will be solved? 100 dBA sound, that means here we'll be writing 100, okay, is equal to 10, then we have log 10. Now here I is measured intensity, I is to be found, whereas I0 is given 1 into 10 to the power minus 24, right? Now tell me, can we very easily find out that what the meaning of this particular thing will be? very easily we can find out. Again, I'm saying this particular thing, the calculated value of this particular thing is very easy to be found. Why it is easy to be found? Because it is nothing but 10 log 10 is 1. So it will be 10 log 10, then I by I0. So gradually we'll find out I, and that will be our answer in watt per meter square. Okay, so it is as simple as that, not a complicated thing, right? Okay, so that is what the numericals look like, and this is what noise pollution we are having.